Okay, is it recording me? There we go. Okay. How is everybody's first assignment coming along? Think you're gonna, anybody having issues with it? Yeah, as long as it's close to 50 seconds, that's fine. Don't worry about that too much. Yeah, the only reason I put a time limit on there is just because I have 100 students and I need to be actually able to grade all of your assignments. And if everybody's submitting 20-minute long tracks, I'm not gonna have time, right? So yeah, 30 to 50 seconds, if it's, as long as it's under a minute reasonably, I just need to be able to grade it, right? Is anybody having any issues with GitHub, pushing your stuff to the GitHub repository? No issues there?
It keeps saying that I don't have access to something, but it keeps actually, like, when I try to pull the code, it says it's either gone or I don't have access, but it actually is pulling the code, so I just want to do.
Well, as long as it's like, you can check the, like the GitHub repository on like your GitHub account, and as long as that's up to date, you're good. I'll be able to see your work, even if it's throwing an error message. So yeah, a couple of people have been getting error messages from GitHub, but ultimately their stuff is up to date. So yeah. Okay, so I guess today I'm just going to quickly finish up showing how to do the second assignment. And then if you'd like, you can spend the rest of the class working on your first assignment. If you're behind on it, you want to just spend an extra hour on it, you can spend class today on that. We're just going to finish up our stopwatch here, as well as go a little bit more in detail for events and stuff, just kind of expanding on what we covered last week, or last class rather. Okay, so we should have our game mode here. And if we recall, we had this event here that we generate on our starting line that tracks when a lap is completed. We bound this delegate to that event. So when we complete a lap, this event is going to trigger this delegate right here, right? And we have this sequence node. And just to review what this is, this helps clean up our graphs to make them a little bit more readable. And it just executes these pins in order, right? So first it does this one, then it does this one, and you can keep adding more pins if you want. Okay. So what we did here is we recorded our lap times in seconds here. We just have an array of floats. So whenever we complete a lap, we just add that time to an array. Now, I also mentioned that I wanted to kind of clean up the time code displayed in the timer. Right now, we're just getting, we were just getting seconds, right? But I figured out here how to create just like a nicer time code on our timer. Excuse me. And the way I did this was I have this time code variable here. The way I created this, I added a variable, and from the dropdown here, I just selected time code right here. And if you hover over it, it says it's a time code that stores time in hours, hours, minutes, minutes, seconds, seconds. So it's just like a cleaner looking time code and looks more like a stopwatch. So get rid of this variable here. But I was having some trouble setting it until I found this function here. And the way I found this is I just right-clicked and searched for time. And I found all of these like time span functions here. I didn't know what these did until I just pulled it in. And I found this one that returns a time span in seconds. And you can see it converts seconds into hours, minutes, seconds, and milliseconds. I then set my time code variable. The way that I did that, so I just clicked and dragged it into here and said set. And you'll see that this is kind of broken out into more pins. That's because this is a struct, right? Everyone here is familiar with the idea of a struct, which is where you kind of package a whole bunch of different data types into one variable that you can pass around in a single variable. You can do the same thing in Unreal Engine. You have these structs right here. And the way that you set each individual element in a struct is you just right click on it. And you can see here it says split pin or split struct pin rather. And it breaks a struct pin into separate pin per element. And you can see you can just set each individual element of your struct. And then I just clicked and dragged that into the string just to test it. And I believe if I run our game here, you can see now we just have like a nicer time code. And another section asked me to figure out how to make the guys jump forward. They saw us up and down. Sorry, so there's a little stampede there. So yeah, you can see now we have this nice clean time code that gives us seconds, minutes, and milliseconds. Right, and I need to change this. No, we are section FS2. Okay. I realize I have the wrong stuff here. Just gonna put your checkpoints in there. So, does anybody want to review anything? Has anybody like fallen behind with checkpoints to the starting line or events or anything before we proceed to kind of finish off the assignment? Does anyone want to take a minute and just have any questions they have answered? No. Okay. All right. So to start, I kind of want to refactor this a little bit. Because right now, if I open up my checkpoint, you can see that our checkpoint gets our all actors of class, gets our starting line. And then we do a little test to see if there's more than one starting line and all of that. And then we bind an event here. So we're doing the same thing that we're doing in our game mode. And generally, it's a bad thing to repeat code, right? So if we're getting this like get starting line and doing this debug check on every single function that ties into the completion of a lap, that's not a good thing, right? So we kind of need to think a little bit more about the architecture of our code. And to do that, we need to understand what our game mode is, right? So I think I talked about this a little bit last class, but our game mode is like an overarching class that exists everywhere in the world, and you can only have one of it. So this is kind of our game mode here. It's a little cloud that sits above our level. And we have our starting line and our checkpoints. This is killing me. Every time the ink would be depends. And we have our checkpoints, right? And we know that our starting line can track and generate an event for when a lap is completed. So rather than have, everything listen to the starting line, our user interface, our timer, and all of that, we can just have our game mode listen, and then have our game mode kind of broadcast another event whenever we complete a lap. And this way, we decouple our code. We don't have like this spider's web of things that are getting references to the starting line, and the starting line then has to get a reference to those things and all of that. We can use our game mode because everything can access it freely. It's available everywhere. We can use our game mode to kind of filter events, right? So in our race game mode here, you can see we've created one event dispatcher here for when the race is completed. And we have that here where we just have our laps completed variable and then the total laps to win. And we do a little comparison. And if you've completed a sufficient number of laps, we broadcast this event. You've completed the race. But it stands to reason that if you haven't completed the race and you've still completed the lap, we can generate another event here called on-lap complete. So this is basically the same event that we're triggering on our starting line, right? On-lap complete. Now, we have more information in our game mode about the lap that we've just completed than our starting line does, right? Our starting line doesn't know how many laps we need to complete, doesn't know, doesn't really know anything about the rules of the game, and it shouldn't have to know anything about the rules of the game. That's what the game mode is for, right? We should separate these concerns out. I believe a big portion of each assignment is something I'm evaluating single responsibility principle, which is a fancy way of saying don't have one class that does a million different things, right? Every function should have a clear purpose and it should only serve that purpose. Every class should have a clear purpose and should only serve that purpose. So if your player character starts to track your time, like the timer and the rules of the game and user input and, you have a problem, right? Because now you have one monolithic class that handles everything, which is not the way you want to structure your software. You want to create kind of small modular pieces, each of which have a single purpose. So in our case, with our game mode, it's to track the rules of the game and to track the kind of progress of the player. Uh-oh, we're getting a little error here. Oh, that's why. Accidentally changed this, sorry. There we go. Sorry, it's having a little error here. Let's fix that. You shouldn't be getting that error. I only got that error because I have 4 different starting line classes for the 4 different sections because I go through creating it each time. And I selected the wrong one. Okay. So I created this event here for on-lap completed, and we can include more information in here than we did before. And to do that, we can select our event dispatcher from in our list here on the left-hand side. And you can see here in our details panel, we can add inputs to this event. So I'm going to add, and if I hover over this little plus button, it turns blue and says new parameter. I'm going to go ahead and add a new parameter. And I can call this one lap number, right? And I'm going to make it an integer. And you can see here where we now call this event, we have this integer input, right? And I'm just going to plug in laps completed into there, right? So anything that listens for this event will now also know how many laps the player has completed because we can pass that information to the delegate that we bind to this event, right? So if we go back to our checkpoint here, we don't want to bind to the starting event anymore. In fact, we're going to move all of this logic and all of this debugging stuff into our game mode. So we only have to do it once. And so here, I'm going to right click rather, and I'm going to say get game mode. Every single blueprint, every single class has access to this function, get game mode, right? That's because our game mode is kind of this global information repository that everything can access, okay? But if I try to bind, if I say, okay, bind to event on lap completed, it's going to say, wait, you don't have this event defined, right? That's because this get game mode doesn't know what our game mode is necessarily. It grabs kind of the base class of game mode, right? So just like here, right, where we have our on component begin overlap and it returns the other actor, like our blueprint is kind of agnostic. We could have a million different game modes, right? We could have one game mode for racing and another game mode for, maybe we have like an arena battle game mode, right? This function does not inherently know the game mode of every single level in our game. But just like before, we can cast. We can say, all right, we don't know exactly what it is, but I know what it should be and what I'd like it to treat it as, right? So we can cast to the game mode that we've defined, right? And if we remember anything about casting, it's basically just saying, right here we have the parent class, treat it as though it is this child class, right? Because our game mode is a child class of the game mode base. I believe we went over creating one last week. I'm not sure if I went through it with the other section. Let's just double check to make sure I went through it with you. To create a game mode of our own, we create a blueprint class and just select game mode base here, right? So we know that our game mode will inherit from the game mode base. And we also know that this get game mode, if you hover over the return value, returns a game mode base object. And so right here, we're just saying treat our game mode base as though it is our racing game mode. And you'll see here that this object pin is of our type BP race game mode, as opposed to game mode base, right? And to clean this up, I can right click and actually convert to pure cast if you want. And now I don't have to feed it into my execution pin here. That's optional. You can have pure cast and impure cast. It doesn't make a difference really. It's just how you want to organize your code, right? So I can right click and it just returns a true or false, whether I successfully cast, or I can have different execution pins for failure and success. In this case, I'm just going to leave it here for failure and success with the execution pins. And now if I drag off of this, and I say bind to event on lap complete, right? Now I have access to my event that I've defined. Right? So here's our kind of our game mode class. We've defined this event dispatcher. We've got our game mode. We casted it, treating it as though it is an object of this type. And then we bound to our on lap complete. Now, I have this event, this delegate here that I've defined, right? I already have this, but you're going to see if I try and plug this in, it shouldn't on lap complete. Oh, compile and save. We're going to get an error, right? It's saying, if we click on this, it'll say on lap completed signature error. The function / event on lap completed does not match the necessary signature. Has the delegate or function event change? And this just means that our on laps completed is passing through an integer. And any function and any event that we try to bind to this is expecting an integer, right? If we don't have an integer, it's not going to work. So I can select my custom event here, and I can go in and I can add inputs. Okay, so I can go click that, make it an integer. I can call it whatever I want, like, lap counts, lap number, right? And now if I try and bind it, it should work, right? Should work. There we go. Right, and now I got rid of that error. Does that make sense? Any inputs that you add to your event dispatcher, any delegate you bind needs those same inputs, right? You need the same parameters on the function that you are binding as you do on your event, right? Otherwise, it's not going to work. And this can actually be kind of tricky because a lot of the prepackaged events that Unreal provides, you can see this is a delegate. They might have like 6 or 7 inputs. And you might not know the specific variable type for every single input required and the order that they need to be in. So there is a kind of a shorthand way of doing this, right? In my event here, I can click and drag and just type in custom to create a custom event, add a custom event. And when you do it this way, it'll automatically create an event with the appropriate signature. Right, I can just call this onLap. Okay, I hope that makes sense. Right, now you can see if we wanted to do anything with the number of laps, we can do it. I don't necessarily know how everything will react and what information everything is going to need. So just be aware, if you ever change the signature, you ever change the inputs, you're going to have to go around and find every single event that you found and just update the signature as well. It might be nice to even have like a Boolean on here, for example. I know in Mario Kart, when you finish when you reach the last lap, a whole bunch of stuff changes, right? Like the music picks up in pace, the cars actually start to move a little bit faster, stuff like that. And again, you just don't necessarily know all the time what information you're going to need to pass through. It can change. And that's how you do it. You just come here, add your inputs, and then go and update your events here. Okay. Any questions about what a game mode is, casting, binding events? Binding events should be fairly straightforward. You should be familiar with it conceptually, so not too worried about that. Okay, so let's add our debug messages here. We had this whole thing where we got all actors of class, checked the length of the array, and printed this debug message. I'm just gonna grab all this and press Control X. I'm gonna move back into my game mode here. I'll press Control V and paste it there. You can copy and paste between blueprints. It's pretty nice. And we're just going to add all of this debugging here. A good habit to get into is where there's the possibility of human error, just include some messages in your log to let the human know what error they're making, right? I'm just going to delete this for now. And let's think of the possible issues. So we're returning every single starting line that we find in our level. Ideally, there should only be one starting line in your level. So the first thing I'm going to do is going to get the length of the array. I can click and drag off of this integer output and just type in the greater than sign. If the length is greater than 1, we have a problem, right? I'm going to drag off of here. If there's no starting lines in our level, that could be a problem. I'm just going to get, right? I'm going to get, actually, no, I'm also going to do another length check here. And I'll just type the double equals, right? So we can do our comparison operators here. These are all familiar to you, greater than or equal to, equal, not equal, right? You can just use the shorthand from code and search for those, and you can find the operators there. Equal to 0, right? So if the length of our array is 0 and we don't find any starting lines, we might have a problem, right? I'm going to add some branch nodes. Again, these are just our if statements. And if either of these are true, I'm just going to add some print strings and include some warning messages. Like here, we'll say, warning. There is no starting line in the level. Our game will not work. And then tell the person who has made the error what they need to do to fix it. Put a BP starting line. In my case, it's called BP underscore starting line underscore FS2. Put it in the level. That will solve it. And here we can say, warning. There is more than one starting line in the level. game may not work as intended. Because it might work, but it might not work. We don't know. There is only one starting line, right? This isn't just for game development. This is just for software development in general. Just assume if there's a mistake that a human can make, that especially like someone who's not a programmer, a designer, if there's a mistake a designer can make, they will make it. 100%. And it's always helpful to just let them know when they're making a mistake and what they can do to fix it. Okay. And then I'm going to drag out of here. Because we kind of want to check this, then we want to check this. So I'm just going to use another sequence node here. Okay. And I can collapse this into a function. I'm going to right click on all of these. I'm going to select all of this kind of debugging node here and collapse to a function. And I'm just going to call this starting line, or I can call this like get starting line. And I probably want it to actually return the starting line. So I can add a return node. Right here, see add return node. And I clicked and dragged out of this and I just typed get. So it'll let us know if we screwed up in any way. And hopefully we only have one starting line. So if we get index 0 of this array, it'll always just return the one starting line that we have. And I can just click and drag off of this and add an output to our function, or I can select the return node and add an output manually. I find this to be a lot easier to just like click and drag and add a pin because it will automatically create the variable of the type, and it saves me from having to go, okay, well, you know, BP underscore and search through and find it. Just removes any human error. Okay. Now we have a function to get our starting line that includes all of our debugging messages and returns the starting line object. All right, so if we go to our event graph here, now you can see we have it here with our output. Probably shouldn't name our output output. We can call it starting line. You can see it just updates there, right? So now we can kind of get rid of this. We have a function that returns it here. We probably want to check validity as well, right? It's valid. Because even if we print these messages and say, oh, there's nothing here, we're still trying to get it, and we might return a null reference. If we return a null reference, our game isn't going to work. Might crash, throw an error. Here the event graph. So this is valid node. The way I created this is I just dragged off of this object pin, released, is valid. Takes us right here. It's a little question mark. And if it is valid, unless completed, then we can bind our event like so. And if it's not valid, well, we already have the error that tells us, but we're just not going to do anything, right? And then I'm going to clean this up. I don't like when wires go through nodes. I like to avoid it where I can. So I can double click on a pin, or on a wire rather, to create these reroute nodes. And this will let me just kind of clean it up a little bit, like so, right? So instead of going through here and then, because once you have wires and stuff going through nodes and this big bowl of spaghetti of different wires and pins going everywhere, it can get kind of hard to read. Right, so just doing this helps clean things up. Okay. Any questions about what we did there, right? Just a little bit of debugging, and we just get our starting line. Okay. All right. I believe your assignment has you what do you call it? Recording an array of times. I'm going to go to our stopwatch variable, our stopwatch component rather here. And in my record, we had this function record time. Right now, it's just returning this float. I'm going to add, make sure that it's known that the recorded time here is in seconds. So I just put a little s in brackets. I'm going to go into this function. And we're also just going to return our timecode variable too. So our functions can return multiple variables of different types. Right? You can see now it has two outputs. I believe we record our time here. Now we have this timecode output too. Wonder. Oh, look at that. Beautiful. The way I did this is I just said add, and it looks like I can just add it to an array. And I can just click off of this and say promote to variable. Right? Or you can go in here, add a variable, make it a timecode type, click the drop down here, make it into an array. Right? Call this recorded times. And your assignment again has you printing the recorded time whenever you complete a lap. But it also has you printing every recorded time of your array when you complete the race. So here, I'm just going to add a print string node. We're going to print our recorded time. We could do it this way. Or we could just bind an event to onLap complete and do it there, right? So we know that we've added it to an array. I'm going to grab my onLap complete and say bind. So we can bind an event here. Now, once again, we're kind of encountering this issue where we have this spaghetti, right? If I try and bind an event here and then bind an event here, everything's going to be crazy and it's going to be overlapping. And that's no good. So I'm just going to right click down here. Actually, you can do an event. I'm going to show you how to bind a function. So we can bind events this way, but we can also bind functions. I'm going to create a function and I'm going to say print lap time. And we need an integer input, right? Which is the lap we've completed. I'm going to add a print string here, right? This is what we're going to do. We're going to print and get our recorded time. We know which lap we've completed. And we can kind of try and turn this into an index for our array. So we can get a copy. Now, this is always going to return at least one, right? So you will never have this event called having the lap be 0, right? Because if this event is being called, you've completed a lap, you've indexed it, you've incremented it, it'll always be at least 1. So we just have to subtract 1. And we can print like so. The way I got this is I just clicked and dragged and it automatically converted the time code to a string. Generally speaking, most things will automatically get converted to strings when you try and plug them into the print string. Okay. Right, you see it's throwing us an error saying, well, we can't bind to events. You can't have this be empty. Here, instead of typing in custom, I believe I can just say create event. I don't know why it's called this. This is really weird, but you get this green node here. I don't know why it's called create event. I kind of don't like this, but it's neither here nor there. And you can see we have this drop down here where it says select function. And here I have my function print lap time, right? You have this drop down of all of the functions that match your signature. And you can see here I can create a matching function or create a matching event as well. Just going to grab my print lap time and compile. Right? Nice and easy. And if I want to clean this up too, I can even do the same thing here. I can say create events. I should be able to find my onLap completed function here. If I can search onLap completed, I can grab it like so. Right, so that just helps you kind of clean things up. If you don't want to have these red pins going everywhere, you can just use this create event function here. Honestly, this is how I typically do it. I only show it this way to start to kind of make it clear. Look, this is a delegate. Find the delegate, right? This is a nice clean way to do it. Right click, create event. You see, this is why I did it this way. If you just right click and try and create an event, you plug it in. Okay, yeah, it'll populate it like that. That's actually nice. And the nice thing here is that it will only show functions and events that match the signature of the event in the dropdown. Okay. Nice and clean. Does this all make sense? Hope this makes sense. Okay. Let's see if this works. I'm going to make sure that our laps, okay, it's set to 3, good. Now if I drive through here, it should print, oh my God, little stampede. How about that? Keep forgetting about that. All goes well. It prints it to the log. You can see it took me 10 seconds to get there. Okay. And we can do the same thing here. We can say bind to on race complete. All to bind to on race complete. We're going to create events. And this time I'm just going to create a matching function here. You see, it gives it this really awful name, BP race game mode FS2 autogen func. It just automatically generates a function that has, again, the matching signature. And this one, we need to print all of our recorded times. So I'm just going to get my array here for each element in the array. Print string. And do it like so. And we could even make this a little nicer if you want like a better message. We can use the append function here. Append. And this allows us to kind of build custom strings, right? So we can say lap space array index. I'm going to add 1 because it starts at 0. And again, lap, you don't want to be like lap 0 was in this time. We're going to say lap 1 colon space. You see, I'm just kind of building my custom string here, building my message. And we just print that to the log. Okay. And I'm going to go down here just to test and set my total laps to win to 1, because we know we're at least completing 1 lap. Or at least it's registering the completion of 1 lap. There we go. And we might want to, again, make it a little nicer too. Can't hurt. Let's change the color, something a little bit nicer, like this nice, I don't know, bright orange. And we can change the duration to 100 seconds so it doesn't disappear right away. And we can even expand and kind of do this here, copy this, go to my print lap time here. This time I don't need to add 1. I can just grab my lap. Now we get our nice kind of formatted message like so. You don't have to do this. You can just print the recorded time as is. I'm just showing you kind of, once you've got the recorded time in place, you can kind of go in and polish it and make it nicer. And you can realistically accomplish whatever you want. I don't expect this. Honestly, if you just printed the float in seconds, that's fine. That satisfies the needs of the assignment. I'm just showing you how to make it a little bit nicer at this point. Okay. So let's, again, I'll up my total laps to win here to 2 to see if that function has also been updated and installing correctly. There we go. Okay, and that's basically the second assignment done. So if you rewatch these lectures and follow along, you are 5 weeks ahead on this class. Okay. And yeah, that's basically the second assignment. That's really all I wanted to cover today. You can spend the remaining time working on your first assignments if you're not already done. I'll be here to answer any questions for the remainder of class. Yeah, that's kind of, we're really far ahead. You guys as a section are a lot further ahead than the other sections at that point. So yeah. Yeah, what's up?
I was just wondering for our cart, if we want to make a bunch of changes, either adjusting the speed or how well it can turn, because I've got some sharp turns in my level, and we're having, I'm gonna go back and then back up and then like keep backing up to go around the corners.
Yeah, I can show you how to modify the cart here. So you can see if I open up the BP underscore cart, well, the first thing I would recommend doing is just duplicating it, just so you have the original, and because physics in Unreal Engine is kind of fickle and small changes can have unexpected results, right? Because if you accidentally crank the torque input here, the torque strength, which controls how fast you turn, you may end up sending yourself into an absolute spin, right? So here the torque strength is set to 750,000. I can just change this to 1 million. See what happens.
Where was that? Oh, steering, right?
Yeah, under the steering variables here. And in your world settings window, so you should have a window like this. It's probably nested next to your details panel here. If it's not, you go to window and world settings. And you have your game mode set here. Just make sure to override this to your, to the cart that you copied, if you copied it. So
Oh, sorry.
you probably have it over here on
Yes,
the
that's the
side.
default pawn class.
Yeah, and just set that if you copied it to modify it, just set it to the copy. So here we can come in and we can set, again, I set up increase the torque strength. You can increase the acceleration force, which is effectively the max speed of your car. So a lot of people wanted like boost pads and stuff. We'll probably cover that once we've covered the remaining assignment. We'll just kind of do fun stuff to make your levels more interesting. You can increase the acceleration force. The suspension length and strength controls, like you see those 4 red lines, those are the suspension casts. And so you can increase the length to make your car sit higher or decrease it to have it sit lower.
Is that just a look mostly, or is that also like how it kind of lands or whatever?
It controls how it lands because the way that it adds force is it adds force at the location of the wheelbases. So where the suspensions actually hit the ground, that's where it's going to apply force. So it matters more when you're like going off of jumps and landing and stuff, because if you land, say, like on one wheel and you keep pressing forward, it's going to apply force kind of at this point in the car, and you'll kind of make it turn, right? So yeah, let's just set let's increase the torque strength and see if that messes with things at all. Okay, we are getting a bit better turn radius. We could increase it even more. Let's go let's go 1.5 million, see what happens. We might spin out. Right, so yeah, we can see we're turning on a dime now. So that would be, you could change the torque strength to like 1.5 million and give you some sharper turns. So the way the torque also works is it only works if you're accelerating, obviously, because if otherwise you'd be able to just like turn in place, which would be weird for a car. Cars don't work that way. Yeah, that's how you mess with the steering inputs, like the acceleration force, not the acceleration input. I'm gonna set this up to like 10,000, see what happens. We're gonna go off like a rocket ship, I think. You can see we just, okay, not super noticeable, so let's set it up to, I don't know, 100,000. Go crazy fast. Let's see. Okay, so it's actually not affecting us as much as I thought. Oh, that's because I'm not, didn't set the world settings correctly. I didn't update my card. Hey. Right, it's a bit much, okay. This is why I copied it, right? So this is why I still have the original one to go back to. 10,000, maybe that's a nice one to do. Let's see. You can see we're moving quite a bit faster. We're turning on a dime. Oh no. Actually, moving super fast isn't so bad because moving a little bit faster, because you can see that I'm actually just kind of going over the sides of the tracks as opposed to, well, for the most part, unless I catch them at an angle. Yeah. So yeah, that's how you mess with it.
Oh, that's perfect. Other question is the one I had the other day where I've got like a number of ramps in my level and it goes up over the ramp and we're flying and then at some point we just stop and immediately drop.
Okay, let's add, I'm gonna add a ramp and see what happens.
Very anticlimactic.
Modeling mode, out of box. I'll just scale it up like so.
You said there was the suspension length or suspension strength that might it's also sometimes when it goes up onto the ramp, sometimes it like jolts all over the place. With
Yeah.
Length more, it might.
So the suspension strength controls how quickly it will, so like when you land, you can see kind of like, yep, it controls how fast it'll push you back up to the maximum length of the suspension.
So
Right.
correct the whatever issue that just happened.
Exactly.
Okay.
Honestly, the suspension thing is mostly aesthetic, mostly. It's just to give it that like nice kind of cartoony wobble effect when you're driving around. Okay, we're going to merge, I guess, two of these. Model, polygroup edit, and select some edges. Select this one and this one. Let's see if we can just, well, double it. Selected edges must be boundary edges. I don't know what that means. I don't know what that means. Let's see how we can just like use these two edges here. Just gonna do that to create a little ramp. Okay, good enough. Good enough. And then I'll just move it into the ground a little bit. Quick and dirty. I can spend the next hour trying to figure out how to fuse edges, or I can just get it done to test this, see what happens. Let's see if we can fix this. Now we have our ramp. We go up, we go over our ramp. And it seems to be working fine. Right? Yeah, like yes, you kind of have momentum, but like basically what's happening, right, is you're moving through the air, right? So you don't generate acceleration when you're not on the ground, right? So you go off the ramp, right? And you have kind of this much force as you're going off the ramp. And as you're moving, there's also drag being applied to your car, right? So your acceleration basically just kind of tapers off until you have no like thrust, you have no forward motion. And then because there's no forward motion that way, basically the drag pulls you to a complete stop and you kind of do this, right? How would you prefer, like, if you want the ramps to be kind of like, maybe like have them glide down like
A
so?
little bit more, yeah, because like, at least the ones I've got for mine, it's very dramatic where it goes up and we're flying and then suddenly like, it just starts tilting and just. So even if it's just like the acceleration, maybe it goes, it's draining slower or it's getting diminishing slower maybe, so that it's still kind of like
Mhm.
going forward for a longer period of time, but I don't know where you find that.
Absolutely, I can show you where you can find that. That is in the physics settings. So let's open up our cart again, BP cart _1. So this box collision component is what we're using to handle all of the physics, basically, right? You can see here we have it set to simulate physics. And then we have these two damping things. And you can see we have linear damping. This is the drag force that's used to reduce linear movement. So this is the, that's basically the magnitude of this force here. I don't know, like the reason I have linear dampening is if I set this to 0, and so like there's no drag applied to our cart, we'll go off of our ramp. Well, first of all, if I just press forward like so, you can see this, just the force of the suspension sends us wild, right? If I press forward,
It's just gonna go forever.
it's going to go forever because there's no drag, right? So we need some linear dampening. Some. I could also probably solve that by like reducing the suspension strength and stuff and try and make it work. But this is kind of what I said first thing is like small changes in physics can have unexpected results. Right, and
No, it's perfect.
it took me quite a while to kind of just like tweak these inputs to get a result that was like stable enough to work. It's fun. I like playing with this, like, right? So now we have our linear dampening set to 1. So we have some linear dampening. We're still going super fast. Oh man. Right, you can see, right? By doing so, we just like the force that we apply just carries us so much further, right? So the way I would do it for a ramp, right? So let's say like, okay, when we're driving, we want more linear dampening. But when we're in the air, we want less linear dampening, right? And this is to kind of reflect like when we're driving, part of the linear dampening that's being applied is like the friction of the surface that we're on, right? And that's being applied to the tires and it's pulling us back. But when we're in the air, we want less. We have a function on our car, I think it's called like is grounded here. Is grounded. Yep, is grounded and right here. And you can see all this is doing. This is a line trace function. What a line trace does is like it has a start point and an end point, right? Point A, point B, and it just draws an arrow and says, hit something, right? And it's a fairly cheap function. Like you don't want to spam them, but like something like this to just check if you're on the ground. All this is doing is drawing a line straight down based on the length of the suspension to say, are we on the ground? Are our wheels touching the ground? And then it returns this Boolean. If we hit something, then we know we're on the ground. And if we didn't hit something, then we know we're not on the ground. So true, we're on the ground, false, we're not on the ground. So in our event graph, we can go to tick, and we can pull in our is grounded function here. It just returns this Boolean. And I'll show you something here called a select node here. This is just like an if statement that just chooses between two variables, right? So we can just add a couple of variables here. I'm going to add a float variable. I'm going to call this rounded linear dampening. And I'll add another variable called aerial linear dampening. Right? And so the ground, I found 3 was pretty good. It brought us to a pretty quick stop when we just stopped, when we took our foot off the gas, right? When we stopped pressing the forward motion input, it would start to pull us back a little bit. But in the air, we can set this to something, let's say set it to 1. I'm not sure what the right value is. We'll just kind of play with it until we get one that we like. And I'm going to get both of these variables. And so if we are grounded, we want our grounded linear dampening, that's the true value. And if we're not grounded, we want our aerial linear dampening. And then we need to set the linear dampening on our box. So we can grab our box component and say, set linear, here we go, set linear damping. So first we do this, then we set our linear damping based on whether or not we are on the ground or in the air. Okay. You can also use this and just do like a branch node and call this function twice. I just like the select node because this is just a little cleaner, right? We have this Boolean selecting either a true or a false value, depending on what we plug in here, and we're just setting our linear damping. Let's see if this works. I don't know if it's gonna. I'm also gonna take my acceleration force down a little bit because that was just kind of crazy, a little too much. Let's see if this works. Okay. So you can see when we're on the ground, we have the linear damping we want. Accelerate, we go off here. Whoa, there we go. We have a little bit less linear dampening when we're in the air. We could set it to be a little lower depending on how glidey you want the character to be. Another thing you could do, we'll get into this when we make, we'll make boost pads probably towards reading week, because a lot of people had like boost pads in their level. They wanted to figure out how to make the guy go faster if you drive over them. You could have a volume here at the top of your ramp. And when your guy goes over it, you can say, all right, like reduce the force of gravity that's applied for X number of seconds. That's another way you could handle it. The way you do that is using something called set timer by event. So I just right click and I go set timer by event. You can see it has this like delegate here and this time. And you can basically just say, like you could execute a function to reduce the gravity and then set a timer by an event for like, say 2 seconds, and then have an event that returns gravity to normal. So you could have them kind of like glide a little bit more and then have gravity return to normal here. It kind of like, there's a lot of ways you can do it, and it kind of depends on the exact feel that you want. I'm just going to show you how this set timer by event works. It's actually really cool. So set timer by event. I'm just going to do an event that prints a string just to kind of highlight how this works. Right, so I'm going to have it wait 2 seconds, and then we'll print this. Let's do a custom event, and we'll print a string here. I don't really care about the name of it. Custom event is fine. I'll just have it say hello after 2 seconds. And then we also have this timer handle structure here that allows us to like cancel the timer and stuff like that. There's a whole bunch of functions that are associated with this: utilities, variables, set members. I don't know. There's a lot of, I don't remember exactly all the functions. Okay, here under the time, you can see we can like invalidate it. So if for whatever reason, let's say we're flying and then we hit a wall, and we can invalidate the timer, we can do all kinds of things, right? So the way that I would do reducing gravity is I would just have, again, like a volume, and you would have an overlap check on the volume. And that overlap check would return the other actor. You cast your cart, you would set your variable, and then you would have an event on here that probably has like a float input for the time that just says like reset gravity, reset acceleration input, right? You do the same thing with a boost pad, right? Where, here's our boost pad, right? That's it on the ground. Our car drives through it. The boost pad triggers an overlap event, right? That overlap event increases the acceleration input, like automatically says, all right, set our acceleration input now to like 80,000 instead of 60,000 to make it go faster. And then set a timer by an event for 5 seconds. After 5 seconds, return it to the original speed, right? Reset speed. That's more or less how this is done, right? So that's, if you want to take some time to figure that out, we can try that. So let's see if this is working here. Oh, right, you can see in the air, I'm sailing a little bit more just because there's less drag when I'm in the air. I need to take this torque input down. I'm turning it on. It's crazy. Crazy. No car moves like that. Back. Right, so we go off our ramp and we sail a little bit more, right? 15 minutes. Yeah, let's see if we can do a boost pad. We're here. We're here. BP underscore. Right. Got our boost pad. We'll just add a plane. I'll add a box collision, just like we did with our, we call it checkpoint. With our box collision, we grab overlap, grab our actor, cast to BP underscore carts. In this case, we're using cart 1 just because I'm using it as my kind of like my scratch pad here. And we're going to grab it. We're going to say set acceleration force. And in this case, I'm going to get it and add, and I'll create a float variable on this boost pad, and we'll say like boost strength. You could do it as a multiplier. You could be like, make it go 20% faster, multiply it by 1.2. You can add a fixed amount. Lots of ways that you can structure this. In fact, actually, I think a multiplier is a little bit better. So I'm going to say boost multiplier. And we'll set this to like 1.3. So this boost pad will increase our speed by 30%. And my BP cart, I'm going to create this custom event. We're also going to need to cache our original boost pad at that point. Yeah, our original boost amount. So that's where it gets kind of tricky. You can then create like a struct with all of these variables, with all these values, and then just have like your default set in a struct. But I'm just going to create a float for here again, quick and dirty. Let's just see if this works. Call this default acceleration force. And to start, we will set it to our defined acceleration force here. And this one, we're going to call it reset acceleration. And I'm going to have another custom event here. I'm going to call it boost. Again, probably a more sophisticated way of doing this with like an interface or something. If we wanted to do that, can do an interface. That way we don't need to cast and we only care if the thing can be boosted. I know you asked about interfaces before. The way you create an interface, just go to blueprint here. Blueprint interface, I'm gonna call this BPI underscore boostable. And in my cart, if I go to, I believe, class settings, you can see here, like this class settings tab here at the top, we have interfaces. I'm going to add BPI boostable. And if we double click on our interface here, you can see it's kind of normal, but it's also like we just define functions. So it's just like a regular interface. You just define methods on it, and then you have to implement those methods. I'm going to add boost, and I'm going to add an input here that is a float. I'm going to call this boost duration. And then our boost pad, rather than doing this, which is a bit clunky, you can just call boost. And it's just going to grab the interface, and if the interface exists, and then we can set our boost duration to like 3 seconds. But then we want another one for our boost multiplier. We have 2 inputs now. We grab our compile now. Oh, there we go. Compile. Now we have boost duration, boost multiplier. So we'll boost our speed by 30% for say 5 seconds. And then in our cart, right, where we have, we have BPI boostable, we compile. Now you can see we have this interfaces drop down here where we can see, if I double click on this, it'll add, we can implement our interface like so. And we kind of do what we did. Well, we're going to set timer by event. We're going to wait a few seconds before resetting our acceleration. And that will set our acceleration force to our default acceleration force. And then we will set acceleration force to our acceleration force multiplied by our multiplier. Right. So now we're just communicating between these two things using this like boostable interface. Like, I don't know what things we might add to this game. Like, yeah, we add like red shells, like from Mario Kart. Maybe if those go through a boost pad, we want to boost those too. This way, our boost pad doesn't care what is overlapping with it. It only cares if it's something that can be boosted. And then the actual boosting functionality is implemented using the interface method here on the thing that's getting boosted. So let's see if this works. I'm just going to add a print string here. It says boosted. Here I'm going to add another print string that says boost ended. I'll save. Right now, that's where we're starting, and I kind of want to just test this really quick. Probably add a function in here in the construction script that makes it conform to the normal of the landscape. That's down the line. Let's just make sure that this is working first. Uh-oh. Getting a compiler error. Oh, right. Okay. For that. Can't have 2 functions with the same name. There we go. There's my boost pad. Now my acceleration force goes up. Boost ended, my acceleration force goes back down. I'd say that the this isn't super visible, so I'm just going to scale it up a little bit, like so. I'm going to move it in front of my player. Yeah, this is why a function just to like draw a line trace down get the normal of the landscape and orient this thing to the landscape would be really nice. But for now, we're just kind of, again, hammering this out. Honestly, probably I would use something called a decal instead of this plane, just to like prevent collisions. We'll go over decals in when we go over materials. That is a whole can of worms, so we just don't have time to go over it in 10 minutes. Okay, so we drive over this. I'd like to expose these variables, like the boost multiplier. And I'm going to add a function here for boost duration. Make them float. Make them both instance editable. I'm going to make them go twice as fast and have it last for, again, like 3 seconds. This is why interfaces are nice. Now our boost pad is like, what, 3 nodes and 2 variables and a collision check. Super quick. Super quick to put together. Okay, going super fast. Our boost ends, now we go slower again. Okay. You could do the same thing here. Probably need to define call it a function for gravity. Or like I think there's a variable on here somewhere for gravity, maybe. Calculate acceleration. Oh, yeah. So here I've just said, if we're not grounded, apply like this much force downwards. So I can expose this as a variable. I'll right click, split this construct. I got it here, promote the variable, and say default gravity force. And you can kind of do the same thing as I did with the boost pad up at the top of the ramp here and say, reduce gravity to say 10,000 for a little bit, wait a few seconds, and then return gravity to the full amount, right? Yeah. Got a boost pad, got a way to go off of ramps. That's really it, guys. Hopefully we'll be done all 3 of our assignments before reading week, or first 3 assignments by reading week. We can just spend the rest of the class doing fun stuff that you guys want to learn. I know another class was really interested in AI, so they wanted to like make other carts to race against. I know you wanted to do animations. We can cover animations. Any feature, if you kind of are looking at YouTube videos about Unreal Engine, you're like, yeah, that's a really cool feature. I'd love to learn that. Just send me a message. We can spend a class on it. Right. Okay.
I was wondering what we were doing since we were so ahead of everything. I was like, oh, that's going to just do interesting. Just add more and more random things. Perfect.
Yeah, no, that's exactly it, right? And if you can lead this with like a little portfolio piece, you can say, I've never developed a game before, but look at this. I'm not